Hello, everyone. Good morning, good afternoon, good evening, for whatever part of the world you are streaming from. It's so good to be with you again this week, and today we'll be continuing on Python fundamentals, which was where we left off last week. So we have about two classes left for Python, and by after that, we're going to wrap up and move on to another exciting part of our curriculum. I trust you had a very good section with Folonsho yesterday where he took you through the introduction to mastering cloud fundamentals. That is a topic you'll be looking at in depth like a week or two from now. So just keep the excitement on pause. Then you'll continue the excitement once we are done with our fundamental classes left to be completed. So as you can see from the topic we have for today, we will be looking at building reliable Python ETL workflow. So we're building an ETL pipeline with Python, right? We'll be looking at how we will extract data from our CSV. We've gone through that multiple times. Even though you can extract data from multiple sources, we've looked at from API, we've looked at from CSV. Today, we are initially going to look at extracting from a database source. We'll be connecting to a database through Python. We'll be extracting, doing transformations with Pandas. I would show you a lot of transformation tool and processes you can use with Pandas. Then we would load onto our database. So it is as simple as the workflow goes. We extract, we'll transform, and we load ETL. Okay. So I'll be presenting my slide and I'll just get the video out of the way. And if you have any question, please do post it on the comments. My colleagues are there. I also have like a side eye on the comments, so I'll be looking out for that. Okay. So let me just share my screen. Okay. So I hope you can see my screen. So I don't know if this has been uploaded yet to LMS along with the our code base for today. But regardless, we are going to actually enjoy this section. If you interact properly, ask questions anywhere you feel confused in, I'm always happy to go back and we will look at it together. So, like I said, today we'll be looking at building a reliable ETL pipeline. I'm talking of everything that's to get involved with it, your logging, the controls, making sure that there's no processes breaking without you knowing what it is. Just setting the workflow that it won't easily crash. Now, there's one thing I want to start before we move on into this. When you're designing your pipelines or you're building a workflow or whatnot, build it in a way that you have a feeling it is going to crash. Because that is the best way you're going to implement various processes that even when it's crashed, it won't crash in the fact that you won't even know where to pick it up from. You should build it up in a way that whenever you have an error or whenever it crashes, you can easily, in the snap of a finger, come back in to know what went wrong and fix the problem. So when you're building any workflow, build it with the mind that this is going to crash and it's not perfectly perfect. That is the best way for you to know that okay, you're going to build something, reliable, right? So the essentials, we are going to look at data cleaning because data is not always coming in the right format. Even when you extract your data, most times it will come in dirty. And what I mean by dirty data, there are different types of dirty data. You can come with duplicate values. It can come with some empty values. Some can come with some in lowercase when it is meant to be in uppercase. Some can come with mixed casing, and the data will not look presentable when it is used downstream, right? So we'll be looking at data cleaning. We'll be looking at essentials of logging. Logging is a very, very interesting concept in pipelines, and you're going to see the end-to-end of logging today. We'll be looking at error handling. You will look at how to construct robust data pipeline that scales. Then we are looking at it in practical terms because I have a code base prepared for this class. So we'll see step by step how to build this together. So now, why do data quality matter? Like I said, it's always like a garbage in, garbage out situation. If you bring in dirty data and you deliver it to the business is going to then use dirty data to carry out their analysis. And obviously, the analysis result of a dirty data is not correct, and it won't give them the right result in which they would need to make the informed decisions. Because the end goal is for them to be able to use your data, for they need to be able to use the data to make informed decisions. So if the data is not useful enough to make any informed decisions or make any, or to be able to give any insights, then there's no use of even providing that data in the first place. Data is not just to be fancied and stored in a warehouse. At the end of the day, the end goal is to go downstream to be used by the users in whatever form. So you can't send down dirty data downstream. It needs to be cleaned one way or the other in one step. So that's why data quality matter. So aside from cleaning dirty data, if you create silent failures, that when all the silent failures is, even if it fails, you don't even know exactly what went wrong, right? All these things, once it goes downstream, it will compromise analysis and decision making. Now imagine running reports on your data that has inconsistent casing. You are seeing one name with choice starting with a capital C. In another row, you are seeing another choice starting with a small or a lowercase c. They won't SQL won't read them as the same person. So eventually, when you are doing an analysis on this, it might count the users as two users, whereas it is just one user, but it is just a case of one casing. So this type of thing is what cause some inconsistent results. So the results will become unreliable. So if you invest your time upfront in data cleaning, you prevent costly mistake, you improve the pipeline performance, and you build system people can trust. So quality data is the foundation of every reliable pipeline. Now, what are the four most important parts of data quality and what we need to ensure? Like the example I gave earlier with inconsistent casing. So if we see names stored that, see this John in lowercase, see another John in uppercase, another John starting with an init cap. To us, these three names is one person. It serves as one person. But to SQL, when you're doing an analysis, doing a select count, it's going to count them as three different individual, because they look like three different values. So if we should store them consistently together, maybe convert everything to a lowercase or convert everything to uppercase, you are going to get one name, which is the one name that SQL is going to read, or whatever programming language that is using to analyze their data. Okay. Another inconsistent value is missing values. There are sometimes that when you have null values in your records or you have gaps, it creates a breach, and it is going to eventually lead to wrong analysis in downstream processes. So handling missing values is another part of data quality that you need to ensure that you do in the early stage of preparing the data for business use. Another case is the duplicate records, right? So if you have the same entity appearing multiple times, this is also obviously going to result in a wrong reporting value, because again you'll be over reporting what is not actually there. Another instance is of wrong data types. If you store numbers in text, you won't be able to make some calculations on them. You won't be able to do like a sum, you won't be able to do like a division. That's I'm talking of the business users that are going to make use of this data. They won't be able to make use of some certain functions that they can apply on a number data type. You won't be able to apply that because the numbers are stored as text. Imagine doing a plus, like you're doing a sum on numbers stored as strings, stored as numbers, or numbers stored as string. They won't give you the same results. Or if you want to save your dates, or you want like a maximum date, minimum date, so you want to calculate based on a date function, and you store the date as string, it won't give you the same results. That's why another essential transformation is to store data in the right type. So these are four instances of data quality, four most common instances, because there are many more. But these are the most common instances of data quality issues: inconsistent casing, missing values, duplicate records, and wrong data type. Is the common ones we see in day-to-day data that do comes in. Okay. Now, I'm not this is not the first time we'll be hearing about pandas. During our classes of handling files, reading from files, writing to files, we talked extensively on pandas because it is a very interesting tool provided by Python. I won't call it a tool, it's a library. And I told you a library consists of multiple modules, consists of multiple functions, consists of multiple packages, all packaged together inside a single name called Pandas. So Pandas is not just used for handling files or reading into files or writing from files. Pandas is a very, very good data transformation tool because it has a lot of methods that you can use to standardize and prepare your data. So even from basic operations like stripping white space, when I mean by white space, like there's like a space between your names, like maybe at the beginning or at the end, it is going to obviously cause inconsistency because you can't compare that value to a value that is just standard with just the letters in it. Another thing Pandas can do is to normalize your test case, whether you want everything to be in lowercase or you want everything to be in uppercase, whatever the view is, Pandas is going to handle this properly. Pandas can also remove null value very well. It removes it gracefully without causing any breaking, it removes null value in different format. There are like multiple ways you can remove null values in Pandas, which everything leads to a very good result. So all these simple steps can eliminate common data quality issues, and we'll be looking at it on our code. Okay, so I don't know if now that we all have our Jupyter Notebook installed, or I did give a walkthrough of how to do this in our previous class we had last week Wednesday. So and I also shared this code base with my colleagues. So I believe we should be able to walk along, I guess. So the first thing I've prepared is to clean data with Pandas. We'll be looking at clean data with Pandas. I remember from our previous classes with Pandas, if you want to use a library in Python, you are going to import that library into your notebook, right? You have to import that library into your notebook. If you're using your Visual Studio, you have to import that library into whatever file you're working in. But in this case, we're working with Jupyter Notebook, so you import it into your notebook, and it's a very simple syntax. You import Pandas as PD. And I did explain the reason why we import as PDs because when you're importing Pandas, whenever you want to use any of the module or any function in Pandas, you have to be calling out the name Pandas. But in this case, if you don't want to be typing out Pandas every single time, if we should import it as PD, meaning PD is not going to then be a short form of Pandas. So whenever we need anything from Pandas, we won't have to start typing out Pandas. We'll just type out PD. So PD in this case is standing in for Pandas, okay? So when we import Pandas as PD, now we have Pandas in our notebook where we can work on anything or use any of the functions attached to it, okay? Now the next thing is that I prepared a customer CSV. I prepared the customer data, just a very simple thing, nothing crazy that we're going to use for our workflow today. I remember the syntax to read data from a CSV. You're going to use your read underscore CSV from your pandas function. So I did the pd.read underscore CSV. Remember I said it's the easiest way to read a CSV file. So, and I'm storing the value in a data frame called df. I named it df because I don't want to be typing too much. So df is a very short name for our data frame. So we're going to then call it throughout the rest of our project, okay? So we have df is equals to pd dot the function to read CSV read underscore CSV with our CSV name, which in this case I stored it as customers dot CSV. Now the first thing we'll be doing, I want to see what exactly is in this customers.csv so we'll know what we're working with. There's a function in Pandas called .info. This .info is going to give you information on the data frame you ingested. Your data frame you loaded in this case, because we just loaded it simply from a CSV file. So if you want to see what is there, when I mean by what is there, you want to see like the columns, you want to see the data types of the column, you want to see how many rows the data came with, and so on and so forth. So if you do df.info, we then see that, okay, this table, our customer.csv, which we have now stored in a data frame called df, it comes with 4 columns. You can see column 1, ID, column 2, name, column 3, email, and column 4 as amounts. You can already see the data type attached to some of these columns. This This is the formal data type it came with for the CSV. And Python actually and Pandas actually reads data type from CSV very well. Like it reads data type that comes along with the CSV, even though it is not always correct most of the time, and that is where another place data validation comes in as usual. So you can see here from our df.info, it states that ID is an integer data type. You can see the name column is an object data type. Object means string. Object means string, text, anything that has to be written in quotes is called an object data type on Pandas. You can see email also comes in object data type. You can see amount comes in float. I remember explaining this when we talked about data types. Float means decimal. Anything that's a decimal is being stored as a float. And from here, we can see that some of our columns have 7 rows. Some of them has 6 rows. So this is already telling you, from even looking at it so much, you can already see that there are some columns with null value. So you know that definitely you have to handle some null values here, because the regular entry is 7, but as you can see that some of them are not up to 7. So you're already having that in mind. So another function of Pandas that you can easily look at is .head. So this is the first 5 lines of a data frame for you. That's .head. It gives you the first 5 lines. If you do not want to give the first 5 lines, you can then specify how many lines you want. In this case, I specified 10. So if I do my df.head and I specified I actually want 10 lines, it's going to give me the first because my data is actually up to 10. Is I have like only 7 lines here. So it gave me every single thing. But if I didn't specify how many lines I want, I just do df.head. It's automatically going to give me the first 5. It's going to be the first 5 rows in my data. So you can see it returned the first 5 rows in my data. As you can see the values there. So most times df.head is just used to investigate how your data came in. If you want to just briefly see the formats of your data, you want to see how the values are placed or whatnot before you start the transformation, it's also a very good tool to use, over a very good function to use rather, to easily see it. And aside df.head, we also have another one called df.tail, because everything that has a head will have a tail, right? So if you do df.tail, just the opposite of .head, what it is going to do, it will give you the last 5 rows in your data frame. So in this case, you can see that it started from the bottom, and you can see that the last 5 rows in our data frame was the duplicate records we have under here, all the way here. Another function we can use is sample. So if we do df.sample, this one, it won't give it from the head, it won't give it from the tail, it's just give it from any random position, because you just want to see a sample of how the data looks like, okay? So df.sample, you can see it just chose any one for me. If I should run this code again, it is also going to return a different row. It's not specific on a specific row or any specific ID. It's just give you a sample, very basic sample that, okay, see, this is how your data looks like. What do you want to do? Okay. So that's just the basic flow of at least getting to know how your data looks like in data frame using Pandas. So I believe you can jot this down using the df.info to check for the information on the data frame. Use df.head to see how the values are arranged. df.tail to read it from the bottom, and df.sample picks any number, any row or any record at random and return it to you. Now the next thing we'll be doing is to handling format. I didn't name this well. What I wanted to say was just cleaning data, like handling formats of data, right? So we'll be looking at different varieties of handling, for a data format. The first we'll be looking at is how to convert to uppercase. Another interesting function Pandas came with is how to convert to any case you want. So in this case, the data type has to be a string, right? Because if you're converting to uppercase or lowercase, it has to be a string. So if we use the initial function, in this case, the column we are looking at is name, right? The column of the data frame we are looking at is main, like is name, name, name. So in this case, we are then saying we want to make sure that the name is in a string format, and the string now comes with a function called .upper. So in this case, dot upper is going to then convert everything in our name column to uppercase. So remember that this is the way our column looks right now. Let's do our df.head. Let me show you sample of how our data looks right now. You can see with the way the names are arranged. You have some with the init cap, you have some in lowercase, just different random formats. Now let us run this our code to convert everything in our name column into uppercase. So once we run this, now let's check again. Remember I told you that Python easily overwrites. So if I should run this code again, I easily get back what was there previously. Okay. So now let's run df.head again. Now you can see that all the names has been changed to uppercase because of this function we applied here. You can see everything is now in uppercase, starting from the first to the last that do not have a name and is actually a null value. Okay. Now the next type of handling we'll be looking at is how to convert to how to remove white space. We've already handled this. We've looked at this one. So let's look at how to remove white space. What I mean by white space, I explained to you that, okay, take for example, you have your values in your column like this. You have choice, right? And you have choice. Do you think these they are not the same thing because they do not represent the same thing? But if you should trim these two characters for it to have like, okay, let there be no trailing space, no white space before, after, then they're going to be read as the same thing. Okay, so that's why you have to be very careful when you're, where is my thing? That's why you have to be very careful when you're working with that. So now I'll be looking at removing sorry about that. So now I'm looking at removing the white space, and the function to use, it also comes with the dot. It also comes with the dot string. The function is the strip, strip. So you're telling Python to strip this data. So take out the white space from the front, take out any white space at the back, just strip it into something readable. So once we run this, I want to run this separately. I don't want it to come in here. Okay, I'm just delete this. This is what I'm running. So we have our df name, and the reason why I renamed it here is so it's going to enforce the new column name and the new column characteristic on our data frame. Okay, so we're just going to do the same function using the .str, apply then the .strip function to this. So it's going to then it's going to control and remove every trailing space in the values in our name column. So now let's run this, right? And again, let's see how it returns on our data frame. So you can see, I don't know if you could have seen it earlier, but earlier on, I purposely put some white space in columns here. So now I'm sure with the help of our dot strip, those white space has been cleared. Now the next thing we'll look at, if you look at this column name, starting with the name, starting with init cap, email, you can even see where it said the way this amount was spent. You can do mouse, you can do to rename it, like you can see the way the amount was spent was spelled. This is not correct, this is not accurate. So what do we need to do? First thing first, we are going to use another function in Pandas called rename. Rename is a function in Pandas that allows you to rename the columns in your data frame. So in this case, the way the rename syntax is written is that you have to define the columns in which you want to change. So if I'm working on multiple columns, I would have put this in a list and listed them out using the key value pair. So in this case, remember anything key value is in a curly bracket, right? And then using the curly bracket, it comes the key and comes the value. So in this case, how it appears for renaming column is that the key in this case will be the previous column name that was there, which in this case is amount. Then the value will be then what is the new name you want to replace it with, which in this case is amount, right? So once we define this, define df.rename, there in the function bracket is specified that the columns are this, and obviously the intention behind and obviously the intention behind the rename. And as you can see, another syntax we have here called in place is equals to true. The reason why this is so is to enforce that change on our data frame, because if you do not put this in place equals to true, it's only going to return the results of that change in this single cell, in this single output, but the value is not going to be reflected on the data shared. Okay, but now that we have in place equals to true, it's going to enforce this change on our data frame. So now let us run this code and look at the output. So now we've run our df.rename columns, and we are going to then run this df.head again. It's going to give us an example of how the columns look like. So now remember that previously we had our amount column paired as AMOUT. Now it has successfully renamed to amount without, spoiling any other values or breaking any other values. Now the next thing we'll be looking at is how to handle missing values. Now, before we go into just handling missing values, there's something that I actually like to explain about missing values. It's not all the time that you see a missing value in your data that you just end up, oh, delete that row, that entire row, so there will be no missing value at all. No. So if you should get a missing value, you need to look at two things. Is how many percent of the full data is this missing value? Is it up to 30% of the full data? Or is it up to 1 hour of the full? Is it up to 100% of the full data, 90% of the full data? So if you get this question right, that is what to determine the next step you will take. One tip I got is that if it is less than 5% of the full data, don't bother yourself trying to recreate or whatnot. You can just drop it, like drop the empty row, and everything will be fine. But if your data is more, if the missing value is more than 5% of your data, you need to actually find a way to take care of them without the business going bankrupt. So now, what is the way to take care of? There are different ways that are not even listed here to take care of missing data using the fill method. If we are not going to drop them, it is called fillna. FILLNA is called fillna. So this fillna function obviously comes with pandas, but it also comes with multiple type of methods depending on the type of influencer you are. Okay, it comes with different type of method depending on the type of process you're trying to work with. So if you're working with integers, if you're working with like numbers or something like that, you can calculate some certain you can do some certain operations on numbers, that's integers. You can do a sum, you can do an average, you can do the most frequent, that's your mean, mode, and mean, and whatnot. Using those values, you can actually apply the fillna method using those values. So if you have like a table of your orders or something, and you're having like some of the amounts are missing and some of the prices are missing, using the fill now, you can do like a forward fill to be able to fill it with all the mean of all the data that is being recorded, or to fill it with the most frequent data being recorded or whatnot. That's just another method that I didn't put in the scope of this section. There's another type of fill called backward fill, where you can fill it with the previous value in the previous row before the row that has the missing value. So if you have a value underneath of 100, the row that has the missing value, it is automatically going to get filled with the value of 100. That's another method of handling missing data. But remember, all this stressful method is only if it is like more than 5% of your total data. If it is less than that, not stress yourself and feel free to just drop those values. Now, how do we then come on to drop? When you are dropping a value, you just simply use the function drop now, drop na. So in this case, you are going to then put the subset, which is the column name that you're working with. So in this case, our column name is name. Then obviously set in place equals to true to make sure that this change is enforced on our data frame. That is one. This is for drop. I'm not going to run this query yet because I initially want us to first of all see how to fill in missing records with a default value. So this is not about forward fill or backward fill. This is just anywhere you see this missing value, replace it instead with this default value. that's the case. And that can also be done with the FIONA function. So before we even do that, how we even know if your data has missing values? The only way we knew easily is because we are working with a small data. So I can see everything right here. And from my eye, I could see that I have missing value in email, I have missing value in name. From my eye only, I can see it. But if I'm working with thousands and millions of rows, I won't be able to start trying to use my eye to see all the places we have missing values. No, that's not even standard approach. So we have a function also in Pandas called the ISNA. ISNA. This function right here, ISNA. So if you do your df.isna, don't let me add the sum. Without even adding the sum, if you do df.isna, it's initially going to list out all your columns and let you know if you have any missing values. But as I said that, even if you have a lot of data, this is still not going to be convenient, because I don't think you'll be able to see every single row returned like this. So that was the reason why, along with the .isna, I also added another function called .any. So .isna then .any function is going to tell me, do I have any missing value, true or false? So now, as you can see, it's simply just listed out all my columns for me, and it's telling me, CO in my column ID, it is false. I do not have any missing value. But in column name, this is true. You do have missing value. Same thing in column email, you have missing value. Same with column amount, you do not have missing value. So this will just return everything in Boolean, which is true or false. So let me know if I have any missing value in my columns or not. So from this, you can even see that this is an easier way. If I'm having 1 million records, at the end of the day, it only provides back the columns and tell me, does the column have any missing value or not. So this .isna.any is a very good function to easily tell if your data frame has any missing value or not. So based on what we see here, if I look at sample of our data, I do not want the email cover should drop this email that has a missing value. It is going to drop every single row in my data. So it will be dropping the ID 4, it will be dropping Stella, and it will be dropping the amount. And I do not want that, because it's going to be reducing customers that I'm reporting. So rather still, for a better approach, I actually want to replace all the null values with a default value. So it is not going to break the workflow of analysis, and it will not make the data frame looks dirty, but it will still give us a concrete result. So now, based on that, I then use this function of the FIONA to replace in my df.email, using .fiona, replace every default values with unknown. So this filter is going to replace all the missing values with the unknown, right, with the unknown values. So we just put this right here. So let us run this and see how it is implemented. So now if we should run our df.head to see the values of our data frame, you can see this missing value that was previously there, now it has turned to unknown. So now if you're making a calculation on this column, you easily know where to, you can easily just say, okay, how many of them are unknown? Then you can get a proper figure. But if you do not wrap them up in a default value, it's going to just keep showing up as null, and this can break something downstream or return a wrong indices downstream. Now, another thing we can then look at is that for our name column, if the name is missing, I do not want the column there, right? Because maybe according to the business, name is a very important column. So if the name column is missing from the row, I do not want the column there. So I can easily just use the df.drop now with I told you the way the function is arranged. You use a subset, then and the subset is going to contain what's the column, the name of the column that you're trying to pick out the missing values from. Then you can then write the in place equals true again to make sure that the change is being effected on the data frame. So once we run this, let's go and see the output. Remember that in number 4, we had the missing value of none in our ID of 5 rather. So let us check and see what it gets converted to. So if you run the df.head, you can see right here that the ID of 5 or 4 that was right under there, that had missing numbers, that had missing name, you can see now it has been dropped gracefully. And the only things here are data that has complete records at all time. So now, another instance of data transformation we look at is to remove duplicates, because at the end of the day, it is not out of human reach. Duplicates can be found in records. So the best practice is just how to handle these duplicates, right? So now what do we do? If you're having a duplicate value, you use the function dot duplicated to fish it out. So if I'm going to use the dot duplicated function, it also return it in a true or false kind of way, just like dot instant dot any, to let you know if there's duplicates in your columns or not. So we should run this query right here to show the type of duplications you have. You are going to see that it can tell you that for all your columns from step 1 to for your rows, sorry, step 1 to step 6 is all from 1 to step 4 is all false. There's no duplicate record. But I can see from step 5, step 6 that they are actually duplicate records. Then we'll then have to take care of it as the business pleases. So like in this case, I'm assuming that the business case is that any row or any record without a name is not important. So using that in mind, meaning we are going to have to no, the business logic for this duplicate is that every ID has to be unique. So like two people cannot have the same ID. As long as it's coming to the company's database, each ID has to be unique. So it has the 1, 2, 3, and whatever other ID they are sending to the customers. So in this case, if you are coming to put in a new customer detail that already has an ID, it is going to scream it in it's going to scream it in as a duplicate. So in this case, like I said, if you use the dot duplicated function to check if the column has any duplicate values in its row, he can do that. It can do that. So now the dot duplicated is to check if there's any duplicate value, right? But now for us to then handle the duplicate value, you're then going to use the function drop underscore duplicates. I'll go again. If you want to check if there's any duplicate value, you use the df dot duplicated. But then if you want to check the if you want to now check and remove those duplicate values, you're then going to use the function drop underscore duplicates. And just the same way we have with our drop now, you have to specify the subset, which is in this case is the name of the column you're working with, which is ID column. And you have to tell it if the duplicate gets removed, it will keep the first instance where that record occurred. So if you're having like an ID of 1 with the name and amount attached, then again, like 3 lines after, you have another ID of 1 with the name and file attached. It is going to drop the first ID that it came across in the in the data frame. So now if you apply this, first of all, let's run this query to see if you have any duplicate records. So it's row 4, row 6, and let's drop this duplicate record and let us keep the first instance the record applied in. Okay, so now let's run this. Then we are going to then run df.head to see how it returns. So if we noticed previously that we had some duplicate records with the numbers, we had 4 and 5. So now what we now have to now look at is those positions again. As those duplicates still there, you can see right that we have duplicates right here. Ade was for line 2, and he was also appearing here again with the same ID, number. So in this case, if we should apply the drop duplicate value and we are specifying it should keep the first, so in this case we can see Ade, but it did not keep the second Ade. Do you understand? So it picked the first instance of the duplicate and it leaves out the other instance of the duplicate. Now, so it's hard to convert data types. Remember, I explained to you that if you don't convert your data type properly, you'll be able to miss out on some calculations that you'll be able to make use of if you had your data in a perfect timing. Okay. So in this case, the sample we're using is the amount data type. And in this case, remember that amount is stored here as a float. But if you look at the values of these floats, it has no significant decimal point. This particular data must not necessarily be in a float, but it can be in an integer, right? So it's something that you can say, oh, okay, oh, I don't want it to be a float, I want it to be an integer. And remember, integer is a whole number. It doesn't come with any decimal. So if I should convert this data type to an integer, it is going to then we're going to then see the final output and be able to make further calculations on that column. Okay. So now what's the function we can use to convert to another integer, to another function? We will use the dots. We will use the dots as type, because that as type is going to convert it to any bar value. So we are going to convert it to any data type that we choose. In this case, we are using our integer because I want to strip out all the floats, because I can see that the float is not necessary in this point. Everything is just a point zero, so we are taking it back to integer. So if we should run this is telling the data type of integer. So now let us run df dot head again. Or no, rather in this case, let's see df.info. So we'll see the data type of pressure, and we'll see the data type of the column, and know where to move from there, right? So in this case, the function of making use of is df.info. So if you make use of df.info, you can see right here that the data type that we have of our amount is now in an integer format, which is a full login. Remember, I thought that login is very important and a very interesting concept, because it will give you step-by-step process of how to take care of how to take care of failures, how to take care of trials and your errors and what so on and what so forth. Okay. So the first thing we look at in logging is that logging is a way to be able to, at certain points in your pipeline, to be able to tell what is going on. And even if an error occurs, be able to easily know the source of the error, be able to easily know the fundamental of the errors, be able to fix it in time and debug in time. So there are different levels to login, right? There are different levels to login. You have your info login, you have your debug login, you have the warning error, um you have the warning login, you have the debug login, you have the info login, and you have, I think, the error login, which is going to like return when you have an error or whatnot. We'll be looking at a little bit of all those four main types of login level. But in this case, I want to state something. When you before you start a login, you have to do like a configuration to like set up, what is the initial base flow of your login. So in this case, the initial base flow of our login, we're going to set it up this way. It comes with the following arguments. So the first argument is the dot basic config. So this dot basic config is the basic way to set up a new login section. So we're then saying that the level of our login will be login.debug. But remember I tell you that debug is the rows loaded, you have 250 rows loaded, and so on and so forth. That's how debug works, right? And it's the lowest form of logging. So if I should hard code that my level should be login.debug, I won't need to bother about being able to use any of this function, because um it's going to, you can be able to use any other ones that is on top of debug if you should set the minimum level to be debug. But if I should set the minimum level in my config, if I should set it to info, I won't be able to make use of debug, because debug is lower than info. If same thing, if I should set it to warning, I won't be able to use .info, because .info is lower than warning. So the level at which you set your login to is the level at which you can have as many login method as possible. So in this case, if we set our basic config to login.debug, we'll be able to make use of every single debug tools, be able to make use of every single login level from debug all the way down to error. Now you can see another parameter that we set now in our debug setup, in our login setup. You can see right here we have the format equals to the time, then level name and message. This is a very simple way to put in there that when you are going back to look at the messages from your pipeline, you can easily tell the time for that event. You can write then the message that came with that event. Okay. So now that we've set up our login, I remember it is also a library. Login is a library that comes with Python. And what do I say about every library that comes? You need to do the import login. You need to import it. So once we import login with our function right here, the next step of our basic config, and I've written this each of the level means. So starting with the level of login.debug, we are going to then run this, and this has shown that we have our log set up. Like there's a file right now that's tracking what is being returned. So there's a file that will track everything that's been returned for us to see the proper information on everything that has been logged during the course of running your pipeline. So now let's just see a very simple flow. So right now, if we are using our try and accept block, remember I talked about try and accept block last week, and I said it's a way of pipeline implementation to reduce crash or to prevent excessive crash. So if you should work with a try and error to say, okay, try this, and if this doesn't exist, then do this. So it will just be a total crash or database. It's not about finding the power in it, but if the process fails because of any error or whatnot, let it tell you the exact reason why it failed. So regularly would have done except exception as S as E, but calling all the exceptions can be too broad because there are a lot of exceptions handled there are a lot of exceptions handled in this case. So what we now do is to select a specific type of exception. And in this case, the specific type of exception was called the file not found error. If you should run if you should run something on your local or whatnot and you do not have the file and you try to read that file into your data notebook, you're going to get the error. You're going to get the error message of file not found. So instead of picking up the except that with the login.info of what exactly occurred. So in this case, I think I set it to login.error because I want to see the type of error that occurred and how to fix it from there. So we're not really going to go too deep into this because we are going to still do a proper workflow just down the class. So please just give me a second. Okay, so let me share my screen back. Just give me a second. Okay, so back to what we were saying. We mentioned, so now let's see how to connect database. I did mention that's part of what we'll be handling today. We'll be connecting to a database, reading and writing from a database on Python, because it's part of the workflow of building a reliable pipeline in Python, because it needs to read from a database and also load onto a database in all standard work way. So now, how do we connect a database? There's a certain library that comes with Python. It is called SQL. And SQL Alchemy is a very interesting library because it allows you to connect to various types of database. let me specify. It allows you to connect to relational databases, right? It allows you to connect to relational database. And what do you mean by relational database? Database that comes on premise in rows and column, that e.g. like your Postgres, your SQL, Oracle. All type of relational database can easily be connected to using SQL Alchemy on Python. So once you connect to a if you connect to SQL Alchemy, it comes in with another function called create engine. Now, this create engine is what runs the show. It acts as a bridge. It's going to be the gateway to your database from Python. So it's going to act there as the bridge from Python to your gateway. So the flow of connecting using SQL is you need to import create engine function from SQL Alchemy library, because there are lots in SQL Alchemy that you do not want to start breaking down whatnot. The most important function you need from this library is the create engine, because this is the function that's going to enable you to oh, I think my screen is not showing. I thought I was sharing it. Let me share it again. Sorry about that. It's showing now. Okay, I don't think my screen is still up. Don't know what exactly is delaying that. Give me a second. Let me know if you can see my screen now. Can anyone see my screen? I really don't know what is happening, because I can let me reshare again. Oh, okay. It was from the back end, the technical glitch. Yes, it's a technical glitch. Hold on. I will reshare again. Okay, please come. Okay, okay. I think my screen is visible now. So we're discussing on SQL Alchemy. I told you multiple different types of database, most likely relational database, right? And I said there's a function in SQL Alchemy called create engine. And it is this function specifically that makes you actually talk to those database. So, and I told it acts as a bridge, kind of like a gateway between you and the database involved, right? So what is the workflow? What is the standard syntax to create a create engine, or to create an engine in this case? So first thing, creating an engine, you need the dialect name. What is the dialect name? If you're using dialect name is Postgres SQLite, SQL Server, the Postgres name is SQLite. If you're using just what small instances like that, but that's what dialects technically means. Now, what you my driver name, every single dialect, every single database, it has its driver name. In this case, Postgres has a driver called cyclepg2, and this instance, this Java name is specific to this particular dialect you're working with. So in the case of Postgres, because that's the database I want us to work with today, in the case of Postgres, we have our dialect as Postgres SQL, then we have the Java name as cyclepg2, and this is the exact way you make fun of it. The exact way you make use of it is to add the plus sign. That's why I created this standard format of how the engine is being created. You see, you have to put in the dialect plus driver name. So in this case, follow the process. Now, the next thing after putting the dialect and driver name from the workflow you can see here is the username. What is the username of the database? In this case, the username of my database is called Airflow because I'm hosting a particular database for my Docker. I'm not even going to say much more than this because it's not in the course of the classes. So the username of my database is called Airflow, and the password of my database is Postgres. By default, Postgres do comes with the port 5432, right? But there are some instances that some Postgres might have is currently not available. That 5432 is currently not available. But all those cases are here. But the main thing you should look at is that when you are configuring your connection using your create engine, the next step after using the username and the password is the host. Before I even get to the port, the next step is the host. In this case, there's a host for every database. Every database connection, it has a host, it has a port, it has username, it has a password. So in this case, the host is a local host because again, I'm hosting it on my Docker, which is just directly connecting to my local. So the host name of the database we're working with is called localhost, and the port name I told you by default is 5432, but there might be something, there might be another thing on that portal on that port. So you need to always confirm it before you register the value at 5432. Okay. Now the last step or the last requirements for a create engine to work is the database name. Because initially what you just looked at was just the whole accessibility in the issue that's going to the Postgres engine, which is a bridge that's going to speak within Python and the database. Okay. So now, using those example, now let's properly create our create engine function. So we're storing it in a variable called engine. So it's going to capture the connection string that we created and store it anywhere called engine, because it's easy to easily call engine doing any other thing like as it's easy to call engine down the line in our project without having to think of, oh, okay, what exactly was it named as or whatnot. It's a standard practice to put in all the connection details and name it engine. So now we have our engine variable and we created it with the create engine function. And as you can see, we put in all the required parameters. We have the Postgres SQL plus the dialect, which plus the driver's name, which is cyclepg2. We have the username as Airflow. We have the password also as Airflow. We have the hosts as local host. Then the port is 5432. And the name of database we're working with is the patch and posi database. It's just a database that I work with, so it's nothing serious. Now, what is the query I want to execute? Because I want to be able to, I'll just see if we can read from the database. That's why I put in this select all statement. It's just a testing statement to see if we can properly read from this database. So I know that there's a table on the database called accounts, right? So I want to see if we see everything that's from the accounts table on our database. So now I'm storing it as a variable called query, and the answer to my query is just an answer for my script, right? So I then went up to the onto our data frame. I then stored it into a data frame, right? And I'm going to use another function of Pandas called the read SQL. I can remember I said that Pandas has a lot of function that it comes with that is able to perform a lot of read and write functions. You just need to convert this to the type of system you're working with. Initially in the beginning of this class, we imported CSV with our read underscore CSV. But in this case, we are using SQL. But in this case, we are using SQL. Now, what are the issues here? The first thing first is, what is the query you're trying to run? And the query we are testing is the query that we tested was the select all from account. That's our account table, right? Now, what's the next parameter that read underscore SQL will take? It's take the engine. What is the engine it is going to use to connect to database, be able to give you the results of your query? That is what this does. So now we are storing the final output also in a data frame called the DF, right? So um, the next step for them is to call it out and save the variable in a data frame. And as you can see, using our normal df.info, we can see that we were able to successfully connect our database and from it. So I ran this personally when I was creating a connect to it ourselves, right, and see how it goes. So first thing first, from SQL Alchemy, import create engine. We've done that. Remember, creating our engine with all the parameters. The database I'm connecting to is a Postgres database, right? So what is the dialect? Postgres, Java name, encyclopedia 2 with all the other parameters. Now let's run this. It will take a while. Oh, that didn't take time. The engine has been created. Now the next step, what's the query we are doing? I personally, I went into the database. Let me show you the database. So without even saying it from afar. So this is the database we're working with, right? So you can see right here we have tables in this database, but the tables I wanted to just use for testing at least, so we were able to see the right here. So I don't want to open this because it will take, maybe I don't know, I'm not sure, it won't take time. No, let's see it. Let's see what's now account details. So let it load, or let the query load. I can see the details in my view the details in my account. So I don't know why this is not returning yet. So just hold on. Okay, this is not it. I think, okay, it's still loading. Okay, again, remember it is not, it's just a local setup with Docker, so it will take time to load. Okay. So it has, our query has run successfully. We can see what's in our accounts. We have the ID column, we have the name, we have websites, and so on and so forth. Now let's go back to our Python and see if we will see the same output as this. So if we do our df.info, remember our df right now, what it contains is select all from account. This simple SQL statement. I'm trust we also remember our SQL from Follow short classes. So this simple select statement, select all from account, is all what is being stored into a variable called df. So once we do our df.info, this df is still reading from our initial df. I think that it's good to have better naming convention, but to be very honest, df is a very short thing to write. So now let us run our df here, which has our the parameters. We are reading from an SQL. What is the parameter? It's reading from our initial df. the exact columns we had in our database, ID, name, website, blah, blah, blah. You can see it right here with the ID, name, website, and every other column that is also available on the database. So now we can see that we successfully connected our Python to our database using SQL Alchemy through the create engine function. Okay. So what's the next thing to do? Now let's see our total workflow. Oh, I want to finish. Let's go back. Let's go back to our presentation before we keep on going down the rabbit hole of codes. So what I was experienced into our Jupyter notebook was about cleaning data with Pandas. I told you of the different techniques to clean data with Pandas. You have the dot strip, you have the dot drop now, dot rename, and so on and so forth. So I told you the essential Panda techniques. You can remove duplicates. If you don't remove the duplicates, you can actually fill those duplicates. And I told you the criteria to pick. If the duplicate is less than 5% of your total data, don't bother wasting your time. Just sorry, if the missing values, I'm sorry, I'm talking about missing values. If the missing values is less than 5% of your total data, do not bother wasting time trying to fill it up. You can easily just drop everything, drop the missing values and move on, because it might be less significant to the output of the analysis. But if it is a little bit more than 5% of your total data, then go ahead and use any different method of the fill now to be able to fill in the missing values. So that is there. Now we also looked at how to remove duplicate values. Now let's also look at how to filter rows, right? Let's also look at that. So it's a very simple thing, because with Pandas, you can easily manipulate your data. That's why they call it the data manipulation tool. Here with our DF, let me go back to our previous DF that had an amount. So remember, if I should call out DF now, it's going to give me the DF that we defined underneath with the query. So let me run this query again. So I have a new DF. So now I have my df.info. I have a new df right here. So if we can look at this, we have the next step now is to filter on the amount, right? So now let's see. If we want to say, let us see how many data or how many rows have amounts of greater than, let's say, greater than 300. Okay. So we'll then do it this way. Our data frame is called DF, right? So if we do DF, the open brackets, we want to filter with what is the amount that has greater than 200. No, it's greater than 300. Extensively look at logical operators. The greater than sign. Remember the operator that is used to as do a proper comparison, that's equals to. We have to use the double equals to sign. So let's say we're looking for a value that the amount is equals to 250. So we are going to use double equals to sign to compare. Now we're looking for the data frame where the amount in the data frame is equal to 250. So if we do this, you can see here that we have Collins has amount of exactly 250, and so on and so forth, right? So now let's come back again to our workflow here. Okay, no. Now we've already talked on logging. The next thing logging is how logging transforms debugging guesswork into precision. So I'm not going to just make a guesswork on, oh, I guess this is where the pipeline failed. Oh, I guess this is the workflow needed. No, They are going to actually have a proper decision. Okay, this is exactly what needs to be changed. This is exactly what was implemented, and so on and so forth. So without logs, troubleshooting a failed pipeline is like driving in the darkness. You have no direction on where exactly to go to. So log is your headlight. So it's going to retrace your step. It's going to record every single step you take and every single decision and every single error. So you can easily debug and you can easily debug and know exactly what went wrong to fix it. So now the next slide we'll be looking at would be it will be the different type of logging levels. And I explained this earlier on that the most minimum logging level is the debug, and this is just going to just give you detailed information on what is happening, and it's going to give you a for diagnosis purpose. So if you have like, oh, I've loaded 240 rows in my table and so on and so forth, a debug will be the perfect log level to do for that, because to just tell you point blank the processes happening. Dot info is another login level that will also give you the general information messages that is going on. So to tell you, oh, the job has started, you have 1,000 words processed, and so on and so forth. It will give you exactly as it is. You also have your warning. Warning is going to tell you, oh, something is unexpected, but it is recoverable. So to tell you, oh, see, there's no value present, so there is empty value present, so there's initial value present. Dot warning is going to give you those information. Then you have your error, which is dot error. It will give you when there's serious issue that requires immediate attention. AKA if like the file you're trying to extract from file is missing, or there's connection failed issue or whatnot. The dot error, login dot error will give you immediate information to alert you that, oh, okay, you actually need to proper take proper action on it, right? So the next thing we also looked at here was exception handling, and it's like I said in the beginning of this class, the best way to build the pipeline is to build the pipeline like it is going to break. Like build the pipeline like you are not building something that is strong, because that's the best way for you to be able to implement and know that, okay, you're actually going to be able to recover when there's a failure. And in this case, the most important way of doing that is the most common and important way of doing that is through the try and error block and try and access block, sorry. So the try block is telling that, see, try this task, but if it fails, we fail it with this. So that's what the try and access block is going to teach you, right? And it's going to help you do, sorry. And you can see what you wrote in that the production pipeline, it encounters failures constantly. Sometimes the file might go missing or the connection might drop and so on and so forth. So exception will handle like it will prevent like total crash, and it will also help to generate like it will help to to help to gracefully recover, like it will come back up gracefully without so many loss of important processes and whatnot. So the try and except pattern, it will catch error, to log this error and to decide what to do next. Is it going to retry? Is it going to alert? Or is it going to skip the process? So that is another important extension you need to add. And it's a very graceful way of building pipelines in general. So the next flow we also looked at was a checklist of building a reliable pipeline. So the first thing first, just like we did in this workflow, you have to clean your data. Data is never coming in a clean format. Well, most data that I work with, they never come in clean format. So if you specify it there to clean, if you specify it there to clean your data, people using data downstream, it will provide much more meaningful inputs or outputs in this case for them. So I already showed you different ways of cleaning data and the different parameters to look at when you're cleaning data. So now the next thing you have to do is log everything, implement your logging, log every single step. Then the next step is to handle exception properly, which is with the try and error block, which is a try and accept block. Sorry, I don't know, I keep calling it try and error block. It's try and accept block. Okay. Now, they were looking at data ingestion method and automation, even though I don't think we'll be looking at the automation parts tonight, but we'll obviously be looking at data ingestion parts. And we've handled most of this in our previous classes. I've showed you how to ingest data from API. I've showed how to ingest data using files. And today I've showed how to ingest data from a database with a simple connecting to database, right? So I know that the end goal of the data is for it to land into a properly designed warehouse, right? So you have to be able to know how to ingest and get data from different places, automate the flow to load into your data warehouse, and master the technique that actually powers modern data engineering pipelines, because there are a lot of modern tools that do proper ingestion process, but I'm not covering them because of the course today. So now, what is data ingestion? Data ingestion is process of collecting and bringing data from various sources into a storage system for further processing and analysis. So it's a critical step in any data pipeline, and it's actually is going to it's the first step. Actually, not just critical step, it's the first step, because if you've not ingested the data, what are you cleaning? The data has to be initially ingested before it will then be cleaned or transformed or whatnot. So there are different types of data ingestion. We have the batch ingestion. And in this case, the type of ingestion that happens at a specific time. So you can specify that, oh, you want data to get ingested daily, or you want it to be ingested hourly, or by 2:30 every day, let this data get ingested. That type of ingestion is called a batch ingestion. So the periodic load of data at scheduled intervals. So a typical example is the nightly sales upload that to consolidate an entire day transaction into the warehouse, right? Another type of ingestion is called the incremental ingestion. So in this case, it's also going to be at periodic moments, honestly, but the difference is that unlike a batch ingestion, it is going to reduce processing time, because if you've it's not going to do a full load. It is mostly used in transactional data type, like when you have like customers that have bought from you today. So if you do a batch ingestion to bring in all those customers into your data warehouse, the next day you don't need to bring in all of them. You only need to just incrementally add the new ones to the list of your current customer. So that's what incremental just basically means. You get to add anything new you get to the current level. So that's what exactly incremental does. Now we have the final type of ingestion, which is streaming. Streaming never stops. And it's the most common type of ingestion for all this social media, voice. Because I used to wonder how they get my information so fast. The data is being streamed. Same thing as Netflix. If you watch a movie, before the movie is even over, we should mistakenly like come out of that page or whatnot. They're really recommending new movies to you. How did they do that? It is as simple as that. Netflix uses a streaming platform. They stream and this come and pick me up. So it's just a type of data ingestion that doesn't stop. That's just a summary. It doesn't stop. So it gets data in real time, and it gets continuous data, using the technology. So using the technology. So that's data ingestion. The next step is then look at how to connect to different source. And like I specified that we've gone through this since last week, where we covered how to connect to API, we covered how to connect to tables, and this week we did connect to human nature, and we connected to database and how to extract and read from a database, right? So, like I said, with SQL Alchemy, you connect using the SQL drivers. In this case, we connected to a Postgres dialect using the Circle PG2 driver and whatnot, okay? So we can also connect to flat files, which is just simply connecting to a CSV file. And I showed like three different methods on how to connect to a CSV file. Then the next step is to connect to REST API. That's like API endpoints. And I did show you a picture of, I did show you how to connect to API using the request function, because through the request function, you can request for the data to be gotten to you. And if you're not present during our initial class on API, I'm just going to reiterate. API is like a middleman between two systems. So if you don't want, you can't get direct access to the database. You can get access to the API, read data from that database through the API and get your response. That's what API does. And it gets it through the request function to be able to connect and make your request, which in this case, let the system know what do you need. Then it's going to return to you with a response, which you will store in a variable. Okay. Now the next thing here we have to look at is how to how to connect using SQL Alchemy. And I did show you already in Jupyter Notebook the flow. So it's going to connect the dialect plus the driver name with the name, the password, the host, the port, and the database name you're working with. Okay. Now the next step also is logging, error, and handling, and we are workflow to see how it looks, the workflow that we created for the course of making sure that the implementation is clear. So what does this workflow do? We are going to extract from a CSV. We are going to transform that the data if with pandas, or we're going to load into our database, that's our Postgres database. So first thing first, before we started, I created a log file. Like I created a log file for all our login details and a log level. That's basically a log configuration. So what I did here in line 172 was that, remember that we previously tested out login and we initially created the configuration on our project for login. So in this case, even if we should create a new one, either it won't cut through or it will just keep mentioning, it will just keep appending onto the previous log list, and we don't want that. So that's why I'm going to use the .handlers.clear function to clear whatever login detail is on our project right now, because we are kind of starting afresh. Okay. So once I run this query, there's right now nothing in our login that is being stored. So starting this workflow, I initiated a login, I configured the login setup, which is with this. I set up my lowest level to be .info, and I'm putting the formats in which I want the messages to be. I want it to come with the time that job occurred. I want it to come with the level name, what type of level returning, and I want it to come, I want it to come in that format. So it is going to get attached to the log, and everything is going to be stored in a file called etl.log. And I'm using it in a W mode because I want to be able to write into that file. That's that etl.log. So now, using our basic login info, starting our workflow now, we are going to print out with our login.info to print out ETL pipeline is started. So in this case, you can see right here the first implementation of our login. They were starting our extraction from our CSV. That's the first step. We want to extract from a CSV. So I wrap this up in a try and except block to be able to try and extract. And if it doesn't extract, let it fail gracefully and let me know that, oh, okay, the CSV file was not found and it's stopping the pipeline. Because obviously the CSV file is found, this is not going to throw an error because we already used the CSV file previously. Okay. So now the next step of our data is of our workflow is transformation. So that is why I took my time. This workflow, I just brought everything together. So remember, we did converting to uppercase, we did the incorrectly spelled column, we removed white space, convert the in this workflow, I added again that all the columns should be converted to lowercase so it's more consistent to work with. Then I also filled the missing values in email with unknown. Remember, this is all what we did earlier. So I combined all those things to also put right in this workflow. Now, the next thing that I want to do is that I'm not sure every time that there will be unknown in our email, right? So before we do this right here, let me be sure that there's an unknown value. So that is the reason why I put a condition here. If the sum of unknown values in email is greater than 0, then let it state that, oh, some emails are missing, so it is going to fill it as unknown. So then we do put in our function to then fill in our empty values in DF email with unknown. Now, also, we know that I can see from the column type, the data types are not accurate for integer because we don't want the float to be 0 because it's not significant. So hence the need to convert it to a integer. So not only be able to perform better arithmetic solution on it, but to take up less space because 8.0 is still greater than 8, right? So, and you can think, oh, that doesn't matter, it's a very small thing, but it adds up. Imagine working with millions upon millions of rows of record. Those type of details will add up eventually. So now the next step is to then debug the data type. So not necessarily you debugging, but is you adding it there in the login. So you can come back and see what exactly went out, what went wrong. So now you can validate. We're using our login to validate. First thing is to do login.info. We are trying to now say, let us print out that we're validating the data. Then we're also going to check for any duplicate value because we cannot put in duplicate value into our database. We want to make sure that we're putting clean values into the database. Hence the need to check if there's any duplicated value. And remember that duplicated value that comes the false to a positive. So if it is a true, no need of me writing anything because they do know that okay, there's duplicated value there. So let us go on to the next step to then drop those duplicates. Now, the reason why I implemented the before variable and the after variable is to easily see clearly in our login, like how many rows were there with the duplication. Then after we did the dedupe, how many rows are there now? That's that flow there. Then the next thing is to then confirm and print out again with our info that oh, no information was loyal and no information no duplicate ID was found and whatnot. So once this step is complete, it's then print out oh, validation has passed. So this is just the workflow I created for this particular assessments in class. So you can also build it in any how you want or any information you think you would like to get from the pipeline at every point in time. That's going to determine the particular position that you put in your login details. Now the next step is to then load it into our Postgres database. Remember, then we use the very simple pandas function to write to a database. So in this case, we're not reading, so it will be .to_SQL because we're trying to write into SQL. So you use the to_SQL. So now the first thing is that what's the table name we are creating? We are creating a table called customers, and we are connecting through our engine. And index equals to false because we're trying to read the data frame of pandas. And remember I told you that pandas, in the data frame of pandas, it usually comes like an index, automatic index. Whenever I create a data frame with pandas, it comes with automatic index. And it gets very annoying when you're trying to load these tables or load this data frame into a CSV or load into a table with with the index because it's going to be wrong. And again, remember I told you Python starts with 0. So this index is going to be starting with 0 and might confuse things. So best practice when you're loading into a file or loading into a database or whatnot, always specify that the index is equals to false so it won't pick up the self-assigned index from Python. So now our database has been loaded into successfully. I put in a .info that I want to see exactly in my log file where it tells me, oh, a file called etl.log. Remember right here, we stored everything in a file name called etl.log. Now remember our with statement, we're able to open a file. So using our simple with open etl.log.read mode, we're trying to read into this file. Let's print out everything that is there. So if I should print this out, you can see every put this to be in production settings. Because if I can come here the next day and I look at everything, you can see the timestamp, the exact time it happened, you can see the login detail, which is see how very interesting this is to implement on regular base. Okay, so now we'll be looking at automation, but I don't want to go into that today, but it's not class tonight yet. So we'll actually interact and let me know any section that you need us to go over with or any parts of the workflow you do not understand. So we'll go through it again and see where and the angle at which it's actually become clearer. So now open for questions. Let me know if you have any question, anything that you need further clarification on. Your quiz will be coming up soon. Just know it out there. So if you would like to rewatch any of the videos, now be the best time. You'll be having your quiz coming up soon. So you most of the what will be set up will be what has been conversed right here in class, not even just from the slide or from the code base. So to actually do you a favor and also do we the tutors a favor, because we can easily see the section that would need more clarification or the section that we'll need to go over with again. Okay. So in the absence of no question, we might have to end the class, then meet back tomorrow for conclusion on our Python classes and to maybe look at another workflow in preparation for our upcoming tests and projects. So in answer to no question, thank you for joining tonight and I hope you did learn a lot. We'll see you again tomorrow and complete the rest of what we have for this course. All right then, have a restful night.